Let's look at some special cases and take a quick look at dividing polynomials. So, our first special cases are called the perfect square trinomials. Perfect square trinomials. So this comes from taking a plus b squared or a minus b squared. Now, a very, very common mistake is for students to take a plus b squared and say that that is equal to a squared plus b squared. That is not true. Don't do that. Please don't do that. Instead, what will be helpful is if you have a plus b squared is to always expand it so that you're seeing it as a plus b times a plus b. Because then when you see that, hopefully that'll make you think of FOIL. So we want to FOIL that out, and that makes sure that we don't miss that middle term right there. Same thing with a minus b squared. It'll be helpful to write that out as a minus b times a minus b so that you know to FOIL. And then you get that middle term. So perfect square trinomials, just be careful that when you're squaring, you are in fact FOILing those values. Then this case right here is called the difference of squares. And it comes from FOILing with a plus b times a minus b. So when we do this, when we FOIL, we're going to have a times a plus a times b minus a times b minus b squared. And with that, those middle terms turn into 0. So with that, we're just left with a squared minus b squared. So it's just a nice case where that middle term cancels out and it comes from that difference of squares, that a plus b times a minus b. Okay, let's try these out. So x plus 5 squared, I immediately am going to go ahead and write down x plus 5 times x plus 5 so that I know to FOIL. And in FOILing, we're going to have x squared plus 5x plus 5x plus 25, which will simplify to x squared plus 10x plus 25. So there's our perfect square trinomial. Similar idea here, but with subtraction. So again, think of FOILing. So we'll have y squared minus 3y plus 9. So that'll be y squared minus 6y plus 9. Okay, 6 plus 7x all being squared, so I'm going to write that out as 6 plus 7x times 6 plus 7x, and I'm thinking of FOILing. So 6 times 6 is 36, plus 6 times 7x, plus 6 times 7x, plus 7x times 7x. So we have a 49x squared plus 84x plus 36. All right, last one here is our difference of squares. So, in fact, let me show you two ways to do it, with a shortcut and with FOILing. So with FOILing, I'm going to have 3x times 3x plus 3x minus 1. And those middle terms are going to cancel out, so I'm going to have 9x squared minus 1. Another way to go about this is to recognize that you'll have the difference of squares. So we're going to have something squared minus something squared. It's going to come from that first term of 3x and that second term of 1. So that would show us our 9x squared minus 1. Either way works. All right, quick overview of dividing polynomials, and we are actually going to skip these last two. We'll see these later on in the term, but not right now. Okay, when you're dividing by a monomial, what you can do is separate up this division. So you could think of it as 10x to the 5th over 2x minus 8x cubed over 2x plus 4x squared over 2x. And by doing that, it'll be a little simpler to simplify term by term. So 10 divided by 2 is 5. X to the 5th divided by x would leave us with x to the 4th. Minus 8 divided by 2 is 4. X cubed divided by x, so 3 minus 1 would leave us with x squared. Plus 4 divided by 2 is 2. X squared divided by x would leave us with 1x. And that'll do it. Let's look at a more complicated scenario here. So 2x cubed y to the 4th over 10xy minus 4x squared y squared over 10xy plus 6x squared y over 10xy. Okay, 2 divided by 10 is going to be 1/5. And then x cubed, 1x cancels out, so we'll have x squared. Y to the 4th, 1y cancels out, so we'll have y cubed. Minus 4 divided by 10, that'll be a 2/5. So x squared divided by x is x. Y squared divided by y is y. Plus 6 divided by 10 will be 3/5. And we'll be left with the x, and then y divided by y turns into a 1, so this cancel out with each other. So you could leave it like this, or if you want to turn it back into a single fraction, we have our common denominator of 5 there, so we could just combine everything in the numerator and divide it all by 5. And there's our properties of polynomials.